Hi everyone, welcome back to another video. In this video, we are going to be learning how we can create our own CI/CD pipeline and deploy our code inside Amazon EC2. In this video, we will not be deploying one, but instead we'll be deploying two applications inside our EC2 server, and all those things will be done using Code Pipeline, where we'll be using AWS Code Build, AWS Code Deploy, and much more. And finally, we'll be also learning how we can set automatic server restart using Process Manager, so that if in case our application get crashed, it should be capable to restart automatically. So let's learn how we can use AWS Code Pipeline. So here I have a backend for customer support, and here I have a front end for customer ticket raising portal. So this is how it looks. This is the React application that's running in port 5173, and the backend that the React application use is this one. It's a Node.js backend that's running on port 9000. Basically, it's a simple React web application where we can just log in, and all the processes happens in our backend. Here we can raise a new ticket, log out or delete. This is a very simple application, and all the processing happens inside our backend. What we want to deploy both of this application inside our EC2, and not only deploy both of the application, but also create a CI/CD pipeline, so that when we push any changes inside our GitHub, it gets automatically triggered and started building the code and deploying it inside our EC2 instance and restart the server, so that we can focus on making changes inside our code and don't worry about pushing and deploying the application. For this, we are going to be using AWS Code Pipeline, AWS Code Build, AWS Code Deploy, and much more. Here I am on the AWS portal. First, we need to create a server where we are going to be deploying our code. For this, we need to search for EC2, or you can click it from your recent visitor. Here we need to visit instances and launch a new instance. Let's name anything. In my case, I'm just naming it as dev server because we are using this server for development. And for this, let's just select Ubuntu as our image. Now you can select any instance type. For this, I'm just selecting a small instance type. For this, I'm using P3A Micro. It has 2 CPU and 1 GB RAM. Here we'll be also requiring a key pair. Let's create a key pair. Let's name it as our key. Create a key pair, and key pair will be downloaded. For networking, let's keep auto assign IP enabled, and also let's disable SSH because we are not going to be connecting our EC2 instance using SSH. We'll be using SSL for that. Let's allow HTTP and HTTPS traffic from anywhere. For our test, 8 GB storage will be enough. Next, here we'll be requiring an IAM instance profile. For this, let's just create an IAM instance. Let's click here. Here, we'll be creating a new role. It will be for our EC2 instance. Select EC2, click on Next. Here, first, we'll be requiring the SSM managed code. We'll be requiring SSM managed instance code, so that we can connect our EC2 instance using SSM. Then we'll be requiring code deploy. Let's use code deploy full access. Then we'll be requiring S3. For this, I'm just using S3 full access. Let's click on next. Let's name the role as deploy code to EC2. We are allowing this 3 policies. Let's create this role. So this was the role that we have created. Now, if we refresh here, this was the role that we recently created, deploy code to EC2. Select this. And now we can just launch our instance. So now our instance have been created. Now we have created our server and it's running. For continuous integration development, we need to create a code pipeline. Our server is running. We can just click here and click on connect. We'll be connecting using session manager. Let's use this option. If you have not provided the IAM role, then you'll be not getting this option. Click on connect. Let's go to root options using sudo su. Now we are here. Let's verify that we have Node installed in our system or not. So we don't have Node installed in our system. Also npm will be not installed. So both Node and npm are not installed. For our job, we'll be requiring Node.js and npm. Let's just install it. But before that, we need to update the system. Let's use sudo apt upgrade, sudo apt update, and sudo apt upgrade. This will upgrade all the packages that are there inside our Ubuntu system. Like we need to upgrade these packages. Let's click on yes. Let's wait until it gets updated. I have pushed both the code inside GitHub. Like this is our backend code and this is our front-end code. You will find that both of the repositories are private. This one has a lock symbol and also this one. The lock symbol indicates that both are private. So you don't need to have your GitHub repository public. For AWS to access and deploy it inside EC2, it can be private. AWS can access private repositories. For that, you need to just create a connection. We'll be doing that in later part of this video. So now our system have been upgraded. Now let's just use apt install node.js. So let's check the version. So node.js 18 is installed inside the system. That's good for us. Let's also install npm now. It will take time because it's 600 MB. Now our npm has been also installed. Let's search for npm-v. And we'll be also requiring pnpm package manager. Our code is using that. So let's use npm-g install pnpm. Now we have installed all the necessary packages that are required for us. For doing continuous integration and continuous development, we need to create a pipeline that will automate the process. For that, inside your search box, just search for Code Pipeline, select this option, open it in new tab. Here we need to create our own new pipeline. So for this, we'll be using code build and code deploy. But first, let's just create a pipeline. We'll do other step one by one. Since we'll be deploying our application to EC2, here we don't have that option. It's only available in custom pipeline. So select build custom pipeline. Then click on next. Here we need to name the pipeline. Let's name it as deploy my code to EC2. It will create a rule. And here we need to select where will be our artifact store. The code that you write and store in GitHub is known as the source artifact, and the code that generates after building the application is the build artifact. Now here it's asking where we want to store that source artifact. Means when we push something inside our GitHub, what this pipeline will do, this pipeline will store that code inside S3, and it's just asking that where it will store the code, inside default location or custom location. If you have some specific custom location that you want to upload, then you can select this option. For now, I'm keeping default because I don't have any bucket for that. Let's keep the encryption as default and let's click on next. Here we need to select our source. For this, our source, we are going to be pushing our code to GitHub, so our source will be GitHub. I'm selecting the first option, GitHub via GitHub app. So here mainly you need to connect your application to GitHub, and after connecting it, you'll be getting that inside your connections. But I'm not going to do that because I already have a GitHub connection enabled. Just select this, and now here we need to load our repository. First, we are going to be deploying our React application. So the name of the repository was customer ticket raise React. This is the repository. Let's just select it. Here we need to specify the branch. It was our master branch. We only have one branch, and inside webhook, this is very important. We need to specify that when we should start triggering our pipeline. So we want that when we push any changes inside our GitHub repository, it should start the pipeline. So let's create event type as push. When we push, let's say our main branch was master. So when we push anything inside our master branch, it should start the pipeline. Let's click on next. Now here comes the build stage. Inside our React application, we have the build script where it will build these static assets inside our dist folder. So we need to write those logics so that we can call the build function. For this, just select other build providers, and here you need to select code build. Here you will be required to create a new project. Currently we don't have anything. Let's create a new project. Here it will be build customer support app. We are selecting as default project. We need to run it on demand, and let's use a managed image, and our compute will be EC2. For operating system, we can just select Amazon Linux. If you want, you can also select Ubuntu, but I don't think it will be much difference. If you are using Linux, then you should be using Linux. Otherwise, you should be choosing any Windows image. And we need to have a new role. If you have an existing role, you can select it, but in my case, I'm selecting new role. And for the build spec file, we'll be supplying the build spec from our code directly, so we don't want to insert it here. So let's select use from build spec file, and build spec file will be buildspec.yml, so we don't need any changes, but we need to write this file. For logs, let's use CloudWatch logs, and let's continue to pipeline. So now we have created our project for building the code. Now here we'll be only having single build. As I told you that the source code that you write when it gets pushed inside S3, it's known as source artifact. So our input will be our source artifact. Means we'll take the input from our source artifact that is stored in AWS S3, and from that we'll be building our code. Now let's process to next step. This is a test stage step. If you want to test your deployment, then you should be using this, but for our case, we are going to be skipping this stage. Now here we have the deploy stage. Here we need to select a deploy provider. For this we'll be using code deploy, but we don't have any application for code deploy. Just click on this menu, expand code deploy. Here just open applications. Here we need to create our first application. Let's name it as deploy my code to EC2. Our compute platform will be EC2 because we are using that. Let's create this application. Now first we need to also create a deployment group. Let's name this group is going to be for our React application. Let's name it as deploy group for frontend. For service role, we need to create a role that will have code deploy access. So again, inside our role, inside IAM, just create a new role. This time it will be for code deploy. Let's select this. We need to allow code deploy to access AWS services. Let's click on next. We need this service, that is AWS Code Deploy role. Let's name this role as code deploy for us, and let's create this role, code deploy for us. This was the role that we have created. So from here, let's just select the role that we have created, that is code deploy for us. We'll be deploying it in place. We don't require any load balancer, so we are selecting in place, and this will be EC2 instances because we are going to be deploying our code inside EC2 instances. Now we need to match our server on which server we want to install. So the name of our server was dev server. We are selecting that. Here it's saying that only one match instance. Let's click here for more details. So this is the instance that we have created, and we have selected the correct instance. Now we want to select that how we should install the code deploy agent inside our EC2. This option, I think that this option is the best. Keep now and schedule update. Just don't select never, then it will be very difficult for you to install code deploy agent. Just either select only once, or the best option will be now and schedule updates after 14 days. We don't require any load balancer. Let's disable this, and in advance if you need any triggers or alarms, then you can select. Let's create this deployment group. So this is the deployment group that we have written. So this deployment group for frontend that we have created. Now inside our code pipeline, build artifact will containing all the files that are generated after building the code. In most cases, now if you are creating a Next.js application, then you will be also requiring the source code. But since this is a React application, we don't require the source code. We only require the generated static files that are generated from the source code. So it will be inside build artifact. Here now it's showing our application. This is the application that we created on code deploy. Here this is the application, and we need to also select the deployment group. This will be deployment group for frontend. Then click on next. Now we have done everything. We can just create our pipeline. So now our pipeline is ready, but we should stop the execution. Now our pipeline is ready, but we are stopping the execution because we have not yet written our build spec and app spec file that we are going to be writing now. So here first we need to create our build spec. Means in this file we need to specify how we are going to be building the code. AWS does not know what we want to do and how we are going to be building the code. We need to specify that. For that we need to create a file, and the name of the file will be buildspec.yml. Let me just copy this. And here inside our React application we'll be creating one more file. This will be buildspec.yml, and here we are going to be writing the logic. Like here we have an example code, but we don't need everything. Only the parts that we need we should be using. Rest part that are not required, you should not be using that. So this is the example. Now let's write some code from this. So here first we need to write the version as it's mentioned here. It should be 0.2, and then here we will write the phrases on install. This install will be happening on the EC2 instance where we are going to be building the code, not our EC2 instance that we have created. So for runtime I had selected Node.js 18 because our EC2 instances we have installed Node.js 18, and in commands will be just installing npm first and then pnpm. Then on build will be running the command pnpm run build, and when we select pnpm run build it will just build a folder inside. When we run pnpm build it will just build the files, and all the files will be built inside the dest folder. So here inside our artifacts, what we want to keep inside our artifacts, so we want all the files inside our dest folder. It's obvious that when we create our build all the files are going to be inside our dest folder, and we only want that for our React application. So this was our build spec file. Now we need to write the app spec file. This will be used for our code deploy. The app spec file is also very similar to our build spec. In this case, we need to create a file name that will be appspec.yml. Inside our React application, again, create a file appspec.yml, and here we need to write some code. Like we need to specify the version, operating system, destination files, and all these things. So here we have a very basic example what we are going to be doing before install and after install. So here we'll be requiring our source and destination. So for this, what I want, inside our home folder here, let's create a folder. Let's name it as servers, and inside servers I will be creating two folders. First will be for front end and second one will be for backend. So here we are just creating two folders at one line. Now we have two folders, one for front end and one for backend. We'll be storing the React application inside front end folder and Node application inside our backend folder. So here let's just copy the version and all these things. Runtime will be Linux, source will be the root directory, and here we need to specify the destination. As we have created the destination, since we want to install inside frontend, so our directory will be home/server/frontend. Let's just copy this and paste it here. Now we need to also specify some scripts like what is going to happen before install and after install. For this, let's just create a new folder. Let's name it as scripts. Here, let's name it as setup.sh. Here we are going to be writing the logic that's going to happen when we are trying to install the code inside our EC2 instance. Here inside our scripts, let's create a file named deploy.sh. Here what we are going to be doing, here we need to write some shell script. So it will be /bin/ because it will be running inside shell, and then we'll just navigate to this folder and just print that deployment is complete. We don't need to do anything because we are going to be executing this script after we have done the installation. So here inside our app spec, the source folder will be our dest folder, not the root folder. Then we need to specify a hook that will be after install. We need to run this script that will be deploy.sh, timeout as 300 and run it as root. So this is our deploy.sh. Here we don't have any such code, just simply printing the text deployment is completed. And now we have written both appspec and buildspec file. Now here we are passing only the dist folder, but we are not passing the appspec file and the scripts. So if we don't pass this, then our code deploy will fail and our code pipeline will not work correctly. So let's add these changes, and now we can just push it inside our GitHub, and then it will start our code pipeline. Inside our code pipeline, we can see that it's in progress and it has copied the source file to S3 bucket, and now it's building the code. If we check the build process by clicking on the build option, you'll find that it's building the code. Now our build is complete and it has also uploaded the build artifacts to S3. Now it will move to the next step, that is code deploy. We can also view the code deploy steps that's happening. Click on view in code deploy. So now our deployment is complete. It only took 6 seconds to complete. Click on view events. And here we can see how much time it took for each of the individual events to complete. Now we can see that code deploy has deployed all the files that are generated after building our React application. For serving these files, first we need to install the serve package. Let's use npm install -g serve, and for now let's just run this inside port 3000. So for that we'll just call serve -l and specify the port as 3000. All the files are going to be served inside port 3000. We were only allowing port 80 and port 443. For this we need to do this modification, and here inside our security group, in outbound rules we are allowing all traffic, and inbound we should be allowing, for now let's just add port 3000 to IPv4 anywhere. Let's save the rules. Now let's copy this public IP address for this instance and let's try to run port 3000. Here we can see that our React application is working fine and everything is working. But one thing you might note that our backend is not yet ready for running. So if we try to do anything, it will not work. Only the front-end part is done and our React application is now working. We can simply close this. Now we have shut down the server. Now if we try to refresh, we'll get error like this port does not exist and all those things. So now we are going to be creating our code pipeline for deploying our backend application, that's Node.js application. But before writing it, let's write these scripts and appspec files so that we don't face any issues on deploying the code. So here for our Node backend application, we don't need to build a code because everything that we write here is going to be same. Here we don't require the build step. So don't build the code for this. Instead of writing the code, we can simply copy this appspec file and paste it here. It will be very similar, like instead of server frontend, it will be just backend, the name of the folder that we have created, like it was here. This is the folder where we are going to be deploying our Node.js backend code. Now we need to write this script this time. Here let's create a scripts folder, and here we'll be also having a file name as deploy.sh. Here we need to write all the codes that we need to do after deploy or before deploy that we want. Here we are only specifying that after we have done deploying our code, what we are going to do next. Here this time it will be a little bit different, like after we deploy the code, we need to first install all the necessary packages and then we need to start the server. Here inside /bin/bash we'll first navigate to this folder, and PNPM is already installed in our system, so we don't need to worry about that. We can just simply install PNPM install, and like this, when we install like here, when we call PNPM install, it will install all the necessary packages, and after that we can just restart the server. But for that we are keeping this aside for now. Just after deploying, we'll just navigate to this folder and just install all the necessary packages, and we can just print that done install all packages. This time it will not be our dist folder, this will be our root folder, means all the files that we have, we are going to be deploying that. And let's try to commit and sync the changes. Now here we are going to be creating another pipeline. Here we have one pipeline. Let's create one more pipeline. It will be also custom. Deploy backend to EC2. We can use the existing service that we have created. This one was the thing. Deploy code to EC2. We are using the same role that we have previously created. Let everything be default. For source provider, again this will be GitHub, and we need to get the repository name. So the name of the repository was customer support backend. Let's just select the GitHub connection, and inside repository name we'll select customer support backend, and our branch will be master. Here inside webhook we need to specify that on push we need to start the pipeline if our branch is master. We don't need to build the code, because the source code that is there, we need to just copy the same exact code. In this case we are just going to be skipping this build stage. Test we also don't require. This time is the deployment step. Here we'll be using code deploy. This time, as you can see here, we are not getting the build artifact option, because here we are only getting the source artifact option. This is mainly the source code that we have written, but for now we have not created any deployment group. So this time inside we'll be using this application only, but we'll create a different group. This group was for our front end. Now we are going to be creating a group for our backend. Let's name it as deploy group for backend. We are going to be using the same service role that we have created, code deploy for us. In place, it's going to be EC2 instance. Name will be our dev server. Install, just keep this option. We don't require load balancer. Let's just create this deployment group. Now don't use this similar group, because you are going to be having problem. For that reason, I have created separate group for separate things. The server is going to be specific, like this group was for front-end React application, and this we are going to be using for our backend development. Now here we are going to be selecting the same code deploy application that we have, but this time we'll be selecting the backend one, because this is for our backend. Let's click on next. Now we have created our pipeline. Here we don't have the build stage. Let's just click on create pipeline. Now source code has been copied. Let's view it on code deploy. So here deployment is successful. It took only 8 seconds. So everything was successful. Now if we check, if you use ls, you'll find that all of our files are here. Now if we try to run node index.js, so here we need to provide our environment variables. We can simply copy and paste that. Let's just copy this, and here we need to create a file nano.env and paste it here. If you want, you can also use AWS Secret Manager. Now let's try to run node index.js. So now it's working fine. For accessing, we are going to be editing the rules. We need to allow access for port 9000, otherwise we are not going to get the access. Let's allow port 9000 and it will be IP anywhere. So now like this, if we try to access port 9000, here we are getting welcome to our support ticket system. It means that both the backend and frontend are working perfectly. But one thing to note that we have not provided our React application, mainly also our React application also have a .env file, like it's calling localhost 9000, but this time it will not be localhost. This time it will be this website, the IP address or EC2 instance, and the port. This environment variable, it mainly stays in public and there's no harm to share. So here inside our build spec, if we check the AWS documentation, we'll find that we can also pass the environment variables like this. So before phrases, we can just pass environment variables. So just copy the key will be this, and the value will be this. But as I told you, this will not be localhost. This time it will be this one. Let's just copy and paste. Our React application will be calling this for accessing our backend. Now we have supplied the environment variables. If anyone is able to view this environment variable, then we don't care because it's publicly accessible. Let's just add environment, and now let's just sync these changes. Let's also watch the pipeline, how it acts. So now it has started the execution. Now let's wait until it deploys the application fully. So now our application has been deployed, but this application will not get auto restarted. Like as you can see that now we need to use some process manager that will automatically restart our server in case of changes, and we don't need to run it. We need to just visit /frontend and then call serve -l3000 to run our React application like this. But we don't want it to call manually. We want to have automation. For that case, we'll be using systemd so that we are able to automatically restart our server in case we do any changes, or if our server get crashed, or if something happens that stop the server, it can automatically restart that. For this you can use PM2 or any other processes, but the easiest one that is inbuilt in Linux is systemd. So here we need to write the script. Systemd comes pre-installed. Let's write the script on systemd that will automatically restart both of our applications. So here we need to visit cd etc/systemd, then system cd etc systemd. Here we need to go to system, and here we need to write our service file. So for service file, let's write it here only. This is our React application. Let's name it as support frontend.service. You basically will have a script like user will be root, and this is going to be our folder where we have all the files. We just pass node is equal to production, and then we'll just call serve -l3000 and restart always after 3 seconds and wanted by multi-user target. So this is just the service. We can just copy this, and here we can just create a new file. For now I'm just creating a support_front-end.service and just pasting this, then saving it. Now let's also write the service for backend. This will also be very similar. Here inside our support backend, we'll be writing support backend.service. Let's just paste this. This time it will be backend. And here let's use node-mod, and port will be your node-mod, and it will be index.js. So it will be backend website in node. So I don't think that node-mod will be installed. So for that, first let's just install npm install -g node-mod. So now node-mod is installed. Let's just check where node-mod is installed. So node 1 is basically installed in user/local/bin. Let's copy this, and also we need to find where serve is installed. So serve is installed in user/local/bin. So we need to also modify the path here inside our service. So let's just copy this to modify it. So it will be cd systemd system plus. So now I'm just first editing the path for serve because it was wrong inside our support service. Here I'm just clearing everything, and here this is the code. Let me just copy it and paste it here. Control X. Now let's just make nano support. This time it will be backend.service. Let me just copy the code and paste it here. Now we have written both the service. For using this service, first we need to run systemctl daemon reload. So it will be daemon-reload. Now it's okay. Let's try to run systemctl enable support frontend. So now we have enabled our frontend service. Let's also get the status of it. So it's enabled but it's inactive, so we need to start it. We can simply call systemctl restart support frontend service, and now if we check the status, we'll find that it's running, started at React applying connection port 3000. Like if we try to access the application, it's at port 3000. This time it's working. Currently we are not directly calling serve 3000, but instead it's just starting the server from systemd. Now let's also work on the backend service. Currently backend service is stopped. If we try to access port 9000, it will give an error that it will not work. We'll be getting the error because it's not working. Now like this, first we need to enable support backend service. So now we have just created a service. Here we'll be just calling restart and also checking the status. So here it's working, it's giving the basic node 1 thing. Let's now try to access it. Here our ticket system is also working, so that's fine. Now let's just try to use our React application like we do. Let's also check the networking tab. Let's try. You can see that here we are getting not secure issue. This thing we are going to be solving inside our next part, where we are going to be learning how we can get a free SSL certificate and how we can avoid this port thing and directly use reverse proxy so that we don't need to expose our ports. Now our application is working. Here we can just create a new ticket. And it works completely fine. And you'll be getting both the source code in the description. And now we need to do one more. Here inside our deployment, we need to just restart our service. For this, we can just call the thing that we are running here, like the last two steps that we did. Here we need to just call, after we have done it, we need to just call systemctl restart backend service, so that after we deployed our code, we are going to be restarting our backend service. But this was our front-end code, so it will be support front-end. This was our React app, so we are going to be restarting our React service. And after restarting, we'll just call systemctl status support front-end service. This is mainly restarting the server and reading the status of the server. And also in our backend, after we deploy the code, here we'll be running restart support backend.service and then systemctl status. Now let's try to push these changes and let's see whether our application was able to automatically restart or not. Let's commit it and let's push it. Also here we'll give the same message, commit it and push it. Now both of our pipelines should work. Both the pipelines are running and both are in progress. So both the pipelines were successful. So our front end is also working and our backend is also working. It's just automatically restarting our server when we are pushing the code. So this is how we create a CI/CD pipeline. I had shown you both the option for creating CI/CD pipeline for your front end and for your back end. Now I hope that you will be able to create your own pipeline. Some steps will be different in your case, but 90% of the steps are going to be similar like this. In our next part of this video, we are going to be learning how we can avoid exposing our port using some kind of reverse proxy, and how we can remove this not secure option by generating a SSL certificate for us and deploying this inside custom domain. And all these things we are going to be learning inside our next part of this video series. So that's all for this video, and thanks for watching and supporting.